Hello and welcome to day 19 of my Advent of Code series for 2020. If you've missed any of my previous episodes, you want to check those out, get caught up with the playlist linked right up there. So today's problem is called Monster Messages, and we are receiving messages from the elves back in the North Pole about a sea monster they think they saw. And the thing is that some of the messages might be corrupted, so we need to check for the valid messages using this set of rules right here, where how it works is if it is followed by a letter, then that means that that rule represents that letter being out of position. And then if it has numbers after it, it means that it has the indices, like those indices mapped to rules, and it means replace in those rules there. And then if it has a pipe, it means or. So that means that for rule 2 here, for instance, it could be 1, which is A, followed by 3, which is B, or it could be 3, which is B, followed by 1, which is A. So that is pretty much how this construct works in terms of the rules. And yeah, so we need to find the rules that exactly match how many that exactly match rule 0, which is just going to be defined in our file. So there are a lot of different ways to do this. I'm going to show you one of the ones that I think is the neatest. And yeah, so go ahead and give this a try, and then we'll jump into my code right now. So the way that I decided to do this is actually just by building a context-free grammar. A popular solution that I saw online was essentially just building a monstrosity of a regular expression string and then checking against that. But the way that I decided to do this is with a context-free grammar, because you'll notice in the first part it says that there are not going to be any loops. But I had a feeling that since it specifically said that, it meant that in part 2 there would be loops, and constructing a massive regular expression like that just sounded like hell, so I decided to do it with a context-free grammar instead. So the way that I'm doing this is first we read our data, which you'll notice is split between our rules and our actual messages. You'll see here by 2 new lines. So I start by going ahead splitting down to that, and then we have our rules in the first part and our strings in the second part. So for our strings, we can just go ahead and split them by line, but for our rules, I wanted to go ahead and parse those into an actual rules dictionary. So what I do here in this parse rules thing is I take in the strings that represent the rules, I initialize a dictionary, I go ahead, split the raw rules, and loop through it. And then I split each line on the colon, and I say that if the first thing after the colon is a quotation mark, then what we know is that what we're going to go ahead and have is an actual letter here. So we can just go ahead and say that the rule is the letter, which is going to be essentially the second character, which we can also just slice like this, because I don't remember if it had rules that were multiple characters long or if it was just A and B. Okay, no, so this wasn't completely necessary. I could have just said the second index there and it would have worked as well. But yeah, so then otherwise that means that we have a set of rules that map to other rules. So what I go ahead and do there is I use this list comprehension to actually build the rules that holds. So what we have here is I sort of thought of it as you have these sequences and they're separated by pipes, right? So what we can go ahead and do is this list comprehension, the main part of it starts with this if right here. So if there is a pipe, then we're going to go ahead and do this part. Otherwise, we're going to go ahead and just return a list that holds the rule that we have parsed so far. So that's just going to be everything to the right of that colon. So that's just going to encase in a list that it matches the data structure of all of our other things. But if there is a pipe, then what we go ahead and do is split on that pipe, and then we can loop through each sequence, which is going to be the different parts that are on either side of that pipe. And what we can do there is we can say, okay, if there are multiple parts in this sequence, so that means if there are multiple different things which are going to be separated by spaces, then what we can go ahead and do is just return a list of it split on those spaces. Otherwise, we just return the single part of that sequence for that sequence, and then eventually those all get put together into our list, which is then going to hold a bunch of different sequences, which are essentially our different options for what things this rule can match. So then we go ahead and assign it to our dictionary, and at the end we return our dictionary. So now that that's done, we can move into our actual checking for our grammar right here. So what we are doing here in part 1, you saw part 2 there, but it doesn't really matter. There's no real difference in code, is I'm using this match function here. So what I'm doing here is I ended up doing everything with generators. The main reason that I went ahead and did that is just because in the end for part 2, we end up with things that could infinitely loop and things like that. So I didn't want to have to try to compile an entire list, check that the length is in the right area and whatever, and then return that entire list. It made a lot more sense to just go ahead and do this as generators. So what we go ahead and do here in this match thing is if run, so what run is going to do is it's just going to go ahead and eliminate characters as they match from a list here. So what we're going to go ahead and start with is we run it with our grammar that we build, and then 0, and then our string. So what we go ahead and do with that is our grammar is just going to be our rules, as you can see there. So grammar 0 as our index because we're checking for rule 0, and then string. And then what we're going to go ahead and do is we go ahead and check first if the instance of the grammar at that point is a list in our run thing. So the reason that we're doing this is we're going to go ahead and see if we are checking for multiple different sequences. And if so, then we go to this run expand function, which I will explain in a second. It's just a simple wrapper. But otherwise, what we can go ahead and say is if we have a string and string sub 0 equals grammar sub 0. So this means if that rule is just a base rule that just doesn't have any separate sequences and just has essentially one rule, what we can go ahead and do is we're just going to yield the string without that first character. So what that's going to go ahead and give us is the thing that we can check at then the next index. So what this is going to do is then as this goes, it's eventually going to, if it matches the entire rule, it's going to get down to being an empty string. And as you see here, since this is a yield, this is essentially just going to give us a list of the string at those different points as it yields things. So eventually we'll get down to an empty string if it matches, and if so, then that is a match and it will get passed into our sums and that string is passed. So the other case that we had is if we actually have a sequence here. So what we're going to go ahead and do is then I call this run expand function. So what this goes ahead and does is it loops through the different sequences in our alt here, which is just what I renamed the index to essentially say this is the alternative method. So then what we do here is we just loop through all those different sequences, and for those we yield from check sequence, which I will get to in a second. So then that is just essentially saying for this, we check all of the different options and then we pass them to this check sequence thing. So now we can go ahead and jump up to check sequence. So what check sequence does, first of all, if the sequence doesn't exist, right? So then if we are just having a thing where it's empty, then we can just go ahead and give back the string because we're not checking anything specific. Otherwise, what we're going to go ahead and do is we're going to take our sequence. So our sequence is going to be a list of our different rules, and we can split that down into our index, which is going to be the first thing in the sequence, which is going to be the first thing that we end up checking, and the rest of the sequence. So what star does here is this is just a simple list expansion. So this is just going ahead and saying, okay, so we're going to have index and we're going to have the rest of the list. So this is essentially like using car and cutter in a list-based language or something like that. So then what we go ahead and do is, if you remember, run yields us a list, so we can go ahead and just loop through it. We can loop through all the different strings that we get by doing run on grammar index, which is now the first element of this sequence, and the string. So eventually that will get us down to our string that is going to hold essentially whatever is run through from the first part of the sequence. And then we can go ahead and check, okay, for the rest of it, we can run check sequence again, because once we've gotten down that amount of the sequence, we can go ahead and just give back that string that we have and say, this is the rest of the string that we haven't checked yet. You have to go ahead and check it against the indices that it needs to be checked against. And that is essentially how our context-free grammar system here works. So we just define all of our rules, and then we just go through and we check, and we essentially whittle down strings until they match our rule, when we will have an empty string. So that is just going to go ahead and be it for part 1. And we can go ahead and jump into part 2. So for part 2, we just have this hard-coded difference of saying this is actually what 2 of the rules are supposed to be. Instead of the rules that we had before, we need to go ahead and replace them with this. So now there are rules that contain loops, so they could essentially just end up being infinite. So a lot of things are unaffected by here, but some things are affected. And the reason why it has this whole preamble here is if you decided to take the regular expression route, you're going to hit some very ugly infinite loops if you try to do it like that. So you need to go ahead and check for that. It goes ahead and gives us another example. and a bunch of things like that. But since we used a context-free grammar approach with generators, we don't have that infinite looping problem. So what we can do for part 2 is just override the rules. So we're saying create a dictionary, start with a copy of the rules, which we do by that 2 stars thing, which is just going to expand that dictionary into our current dictionary, except for override it by saying that 8 is now this rule and 11 is now this rule. And then we can just go ahead and do the exact same thing we did in part 1, and it just works. So that is the benefit of using nice data structures and like real hardcore computer science algorithms instead of just saying I'm going to toss this into a regular expression. So this is in stark contrast to yesterday's problem when I used a really kludgy solution and got to the answer. This is what I think is a clean way to do it for today. So I hope you enjoyed today's video. Be sure to leave any questions you have in the comments down below and I'll do my best to answer those. If you did enjoy today's video, leave a like and be sure to get subscribed to me and turn on post notifications for my channel so you don't miss any of my future videos. And as we're getting to the end of Advent of Code, I want you guys to let me know what you want to see from me next. Do you want to see me diving into more algorithms and things like that, and maybe doing training for like competitive programming, which is something I haven't really looked at, but which definitely looks interesting. So I could do that. And then I have a bunch of other content coming down the pipeline, so I'm very excited about that, and I hope you guys are too. And goodbye, and I will see you in the next one.